Ready? Is everybody ready? All right. So
Ready.
welcome everybody to our seminar tonight. This is something that Paul and Lamar put together for us, really in celebration and recognition of the FAA's Drone Safety Day, which is April 26th. The topic tonight is regarding beyond visual line of sight safety and compliance. And go ahead and introduce the crew here. Paul, you want to move that slide? It's me. I'm here. It's Amy. And I've been in the UAS industry all since 2016. I started in the training space in Virginia, wrote a training program for the state of Virginia, and it kind of sucked me in. I was on the manned side. Now I'm on the unmanned side to do AAM, UTM, all of that stuff. Right for Drone Life, Board of Advisors for Drone Responders, if you're familiar with those, help with workforce development initiatives with the FAA's Collegiate Training Initiative, and doing some mentorship with some others in the community. So really honored to be involved and get to be here tonight. I started a consulting business about 2 years ago. And what I do is I consult folks in the AAM and UTM business on revenue growth. How do you drive sales, marketing, product, and customer service and make it all work together? And so that's what I'm doing now. And I have a short list of wonderful customers who keep me really busy.
There you go.
Yeah. And Paul, tell us about you.
Awesome. Thank you so much, Amy. Thank you, everybody, for tuning in. I did see right around 7 o'clock, we had dropped a link in Vets to Drones. They have their weekly chat on Thursday. So anybody on this call that's not familiar with Vets to Drones, that is a veteran, we're plugging Vets to Drones. So it was good to see. I just noticed like Alex dropped in and whatnot. So I am an Army veteran, worked on helicopters. I'm a North Carolina FAA Fast Team Drone Pro. And was encouraged to do that by Lamar. So anybody in North Carolina or anywhere, it's a huge part of why we're not just promoting Drone Safety Day, but every day is an opportunity to promote safety. I'm an integrated private pilot. I said worked on helicopters in the Army and been involved in drones for about a little over 8 years. Recently got involved in space, but I founded 910 Drones 2018. We're really focused on training and sales. Like tell everybody, it doesn't matter if it's drone from, China, France, America, Skydio, DJI, everybody has to have the same certification. So we're teaching the same material at the end of the day when it comes to safety, right? Safety and compliance, manufacturers is kind of separate. So appreciate everyone. Go ahead and kind of hand over here to Lamar.
Well, thank you. My name's Lamar Ellis. I am also on the FAA safety team as a representative in the Georgia Drone Pro. And Drone Pro stands for We Promote Safety. I'm also the president of Drone Education Services, which is my background is in real estate. I've been doing this since 2014, and I've been teaching real estate entities how to do safe practices and incorporating aerial technology into their um, their workload. I am the president of the Georgia chapter of AEVSI, and really glad to be here. This is really cool stuff. I was so excited when Paul wanted to go ahead and do this, and this is where it's going. And so I'm going to basically turn it over to you, Paul. Let's tell them what we're doing and let's go for it.
All
But
right.
first,
But first, it's Drone Safety Day. So I think everybody on this call is probably familiar with the FAA's initiative to call it a Drone Safety Day. It happens to be this Saturday. And hopefully you're doing something fun with your drone on Saturday. And tonight we're celebrating that by giving you some information about this drone docking system and this live demo with Paul and Lamar's expertise. If you need to learn about Drone Safety Day, go to faa.gov and search for Drone Safety Day. It tells you a little bit more about it and the initiatives there. Paul?
thank you so much, Amy. And again, if there's any, as people are filling in here, if you have any questions, the easiest way to kind of just get in there as we're going through this and things are live, we want you to ask questions. That's part of this live demo. How do you know this is happening? How do you know this is safe? So what is BVLOS? Just really going to point out the dock and the drone that we're using here in the demo and the flight control system, the core of that safety system, and get our live demo. So BVLOS operations, a lot of this has changed since the end of March with regards to public safety and commercial. We know what visual line of sight is. It's kind of funny. I've got my flight-based shirt on, so it's like, here we started with this, then a human had a stick, and then they had a drone, and here's the box. But visual line of sight, right? Pilot sees it. Then we had EVLOS, extended visual line of sight, where the VO is maintaining visual line of sight to make sure we're not hitting anything. And now we're entering that beyond visual line of sight realm. And that is getting divided into shielded beyond visual line of sight. You're using the ground, a low altitude. You're using nearby obstacles to ensure that there's no air traffic in that area. So not sensors, not a human, keeping the drone close enough to the ground or the infrastructure for public safety purposes, right? That's like a more cleared pathway. But for traditional beyond visual line of sight in the commercial, we're seeing sensors. So I do think this graphic needs some evolving to communicate. How do we get to beyond visual line of sight? Well, the dock, it was mentioned here before the call that someone was asking, well, I want to roll this out. What does this look like? How do we accomplish this? Well, first you need a garage, right? You need your dock, the easiest way to communicate. Where do you put your vehicle? Where do you put your car? Where do you put your, to keep it, your plane, right? You hanger it, you put it in that safe, it's online, hardwired, we're not running this off of a Wi-Fi signal connection, right? We need that hardwired Cat 6, your gigabyte speed. You can run it not off a gigabyte, but you're plugged in to power into internet for redundancy, right? For that reliability when it comes to connectivity and power.
Paul,
Yep.
Let me stop you there. You've actually, it has to be hardwired, correct?
Correct.
You can't really take it out there and use your cell phone for a signal on this.
You couldn't if you wanted to run it off Starlink, right? Because you could have a remote location with a Starlink running off solar power, and that Starlink will have a primary router that has a cable plug, a hardwired Cat 6 cable. So there's ways to get remote off grid. You just have to get creative, and you can run like a Starlink, but you got to be plugged in. You cannot run it off of a Wi-Fi.
One other thing, you just now celebrated your first year anniversary of having that docking station.
Yeah, yep.
And so you've been flying it consistently for a year now, correct?
And so yeah, this thing's been sitting out through hurricane season, winter. It's in North Carolina, so it's not like it's seeing Alaskan winters or Florida, Louisiana summers necessarily, but it's gone from 30s to high 90s in variable wet rain conditions. What we're putting in these docks essentially is just the drones that we're traditionally used to, except they're not folding up, right? They don't have to have that breakdown capability. Your matrices, your inspired flights, right? We got to get these things as small as we can to fit them into a car. No, it's designed for the dock. It fits there. It houses it. It keeps it powered on and ready to go. And what's important, and I like this quote, one machine can do the work of 50 or 100 men, but no machine can do the work of one extraordinary man. Meaning, one person with elite, great skills and knowledge is going to be able to do great things. And so I say that leading into the fourth component or the third component of the system is the flight control, right? Where is this being done from? And so by harnessing the cloud, right? Hardware, software, even AI when it comes to operating some of these drones, the response time, right? Integrating it into an alarm system, right? That coordinator, essentially, air traffic control, right? More than one aircraft can be deployed. So we're looking at various hardware being paired with software. And just to speak to the public safety side, Axon with Skydio, Flock Safety with Aerodome, Brink drones with Motorola, and they're all tying things into the remote operations center. So you got to have that flight control system, bring everything essentially into one pane of glass or one location. I need to know my weather. What do we have to do to be safe and compliant? We still have to know the weather conditions. We still have limitations. The aircraft, can't fly in certain winds. We need to know, visibility. There's a lot of factors that can all tie in. So for fun, what do you call a whitey pilot?
A complainer.
A complainer, right? And this is what happens when you type jokes into AI, right? AI photo generators. You kind of give it the quote, and then anyway, pilots shouldn't fly backwards like this. Always face the direction you're going. So who's ready for a live demonstration?
I am.
There you go.
All right. So can we see my screen here? It should be flight base.
I do not see anything except for a small little map up in the right corner. Okay,
See something loading.
there we go. Now, Paul, you need to stop right here, and you have named your docking station and your drone. You want to tell us so that we know what you're talking about?
I have. So let me make sure we have a good level of zoom here. Yes. So the docking station is the first component that you think of, and so that's my first child, Theodore. And then the drone, second. You can see here, Theodore is the dock. It's online. It's green, and then Lincoln is the name of the drone. So the purpose is here. Great presidents: Theodore Roosevelt, Abraham Lincoln, also names of my sons. So Lincoln is currently not online. When Lincoln comes online, you will see the drone turn green. So this is this single pane of glass, this flight dashboard here. You immediately can see what the green area and the red area is. So from a safety standpoint and a compliance standpoint, in this example, that's a house. And so that red area, as I zoom in, you can see that's a no-fly zone, right? It's an abandoned house in the middle of a field, but for this demonstrative purposes, we treat that like a no-fly zone. It could be a water tower, a cell tower, it could be a prison, it could be anything you don't want to fly over. You go in there and you map that out, and that drone knows, I can't fly here. This green area is like telling that drone, this is your sandbox, this is your play area, this is where you are allowed to operate. It's a geofence. And so with these waivers, like a construction site, right, you're going to put a waiver in and you're going to get an authorization to operate within a certain area. And by geofencing that in, that's a portion that the FAA is looking for in a system, because it reduces the risk that your drone will fly away. If you have a hard-coded geofence built into your system, right, it prevents the possibility that the operator, without knowing it, breaches that valid location. On our right-hand side, you're going to see our live video screen. So in the center is our map, our flight profile. When it pops up on our right-hand side is going to be video feed. Our dock has a camera on it for situational awareness and security purposes. And when the drone powers up, you will see the payload. Left-hand side is going to be our telemetry. So if I enter the docking station itself, you will see some more information pop up. Things that we're used to seeing when we're holding a remote controller in our hand, how many satellites we'll have, what's our battery remaining, very important part of flight operations. A very important part about flying an aircraft, what's my fuel burn, how much fuel do I have in gallons, and how much time does that give me in the air? How much time do I have to get to my destination? And I need some reserve.
And Paul, you've done this up to 90%. Is that programmed into the charging station, or is that?
This is programmed in for battery health purposes. The drone sits ready at 90% as opposed to 100%. Batteries that sit at 100% for extended periods of time will have reduced battery life. So we're seeing a lot of ready to go when operators don't know when they're going to deploy their aircraft. They'll keep it at 90% rather than 100%, especially because that 10% battery doesn't give you like such an increased amount of flight time when it comes to the operation. And then when you're recharging the drone and you're trying to get back in the air, going from 20 to 90% is going to take less time. Getting that final 10%, sometimes the juice isn't worth the squeeze. It might take 30 minutes to get the final 10%, but you're only going to get 3 more minutes of flight time. So, but it sits at 90% in order to increase battery longevity. Good question. The dock. So we have the aircraft section and the docking station. This is very important, right? What is the status of the dock? Because the dock is very critical to the safe operation of the aircraft. The dock has RTK, GPS, a GNSS, Global Navigation Satellite System receiver built into it. So it's currently receiving 21 total satellites. That's coming from GPS, that's coming from GPS, GLONASS, Baidu, and there's another one. There's like four satellite systems that this thing will pull, but 21 satellites is what the dock itself is getting, and the dock is relaying in real time corrections to the drone while it's flying. The dock is calibrated when you deploy the dock. You set its location. One other important section, or looking at the dock, it's on main power, it's closed. The temperature inside the dock is 75 degrees, and the HVAC is currently cooling. We have no active health alerts to be aware of. Safety zones. I mentioned our geofence, our green safe fly area, and our red no-fly zone. Those were last synced 21 minutes ago. So as an operator, I know that we have the most current up to the last 21 minutes geofencing. And before this aircraft takes off, it should go through a syncing, and we will see that it actively syncs, and we're good for the most current safe zones. One thing I mentioned that's important is weather, right? What's the weather on site? It's 82 degrees, there's no rain, and the wind is reading currently 0 miles per hour. I am currently located on site, and I can tell you that that is an accurate weather forecast. When we're operating, go ahead.
I was going to say calm before the storm.
Yeah. And so one last thing, we're going to get this thing up in there very shortly, is to touch on when we're looking at beyond visual line of sight operations, not just public safety, but package delivery, construction operations. If you don't have connectivity with the aircraft C2, you're not going to be able to send commands. You're not going to be able to get data back, and you're not going to be able to send commands. So by monitoring C2, monitoring the latency, it allows us to make sure that when we get into conditions that are less than ideal, we can bring the vehicle back and not continue operations. So we can see our current Ethernet speed from the dock to the cloud. And then once the drone connects, turns on, we'll see what our RF link signal is, as well as our network latency in milliseconds. One really, before this launches, that I'll point out here is the drone isn't powered on yet, so the drone doesn't know how high it doesn't know where the drone is, so it doesn't know how high the drone is above the ground, but the drone is currently in the dock, so this value is relative to the drone in the dock. How high is the drone above the dock? And then our safe altitude, GTS, go to safe altitude. At any time, we can command the drone to go to 120 feet. So say there's a low flying aircraft that we pick up on ADSB, right? We can immediately make that drone just descend to a height that's roughly the tallest treetops. There's a nearby cell tower that's probably about 100 feet. And so by descending to that altitude, it's kind of like the safest altitude before completely landing the aircraft. And then our RTDS is return to docking station. This is the altitude. Think return to home. You know, you have that home button on your remote, RTH, return to home. If you hold and mash that button, this is the altitude that the drone will fly direct back to the docking station and land. And the fourth altitude here is our max altitude. This is programmed so our drone will not exceed that 400 feet altitude above docking
Ground level.
station.
Okay. I thought it was AGL, above ground level.
I believe that's relative to the dock itself.
Okay.
And we'll monitor that in flight. So as I zoom out here, that's kind of running through the telemetry on our left, video on our right, and then our flight is happening in the center part. We have some north pointing arrows. We can go 3-dimensional, which will pop up during flight, and then we have different map layers that we can bring in, depending on what your preference. And they're introducing the ability to put in like flight base. You could put LiDAR layers in. You could put, if you create your own ortho maps, they'll allow you to actually import various layers. And so what we'll do here is first thing we're going to do is we're going to put up just like an autonomous mission. So if we wanted to have this, say, at a construction location, it's a farm field here. So we're going to put this up and see and make sure we're not operating over people. We don't have a operations over people waiver. And I know there was some farming. It's that time. It's apparently all of a sudden after all the testing we've done now, today is the is planting day for this plot of land. So we have a short demo here that's just going to run like a traditional 2D lawnmower mapping pattern. So as opposed to having to get to the field, drive out there, set it up, you can keep this out in a location. And it's important, you don't have to set up a base station. You're always going to have RTK. So we'll pick this mission. We can click continue. And so you're going to see right here, here's a nice 2D overview. This is our starting point. Here's our finishing endpoint. And then my favorite is your elevation profile, because if you're flying from here to Orlando, you know, ForeFlight is going to give you a beautiful elevation profile. You're flying, you want to know, where's my drone going to be relative to the ground? I don't want to, you know, operate, you know, too close to in close proximity to the ground. So our safe altitudes, our RTD altitudes, and our operational altitudes are all in relative to the ground are safe. So we can go ahead and hit next. We have a checklist. You can customize this. Most softwares are allowing you to input depending on your operations. What do we need to be aware of? We have authorization to fly. Our network latency is good. It's low. We're roughly around, you know, 100 milliseconds, for 40 milliseconds. We have 6 GPS satellites and a total of 21 satellites on the RTK. Safe location is configured and healthy. So all of our checks for our technical per se, and then our environmental, we're in the positive 80-degree temperature range, no rainfall, no wind, and our geozones last synced 30 minutes ago. At this point, go ahead.
I was going to say, going back to the other checklist, your alternate landing zone. I don't see it on the map here, but can you talk about why you would need an alternate landing zone for the drone?
Yeah, that's a good question. So if you have any kind of failure, let's see if I back out. Let's try a quick refresh here, see if we can get those to pop up. Oh, there we go. Yeah, so alternate landing zone. If you have any kind of failure, fire, if something happens with this vehicle, with the dock in flight and the dock can't open back up, you have an alternate location that's nearby, next door, that's also secured where the drone will land. It's an alternate landing location.
But it has to be flat and level so that you can.
Yeah. It should be. It could be tall. You know, you could put it in tall grass because you're thinking emergencies. It's if the drone propellers or takes a little bit of damage, as long as it's a safe location where if you're off site remotely, it needs to be a safe location where it's secured and there's not going to be risk to people or property.
Well, I know that just for this broadcast, we actually put the safe landing zone on the other side of the house so that you could actually distinguish it. You could put it right next door to the docking station.
Correct. Within the same rooftop, a lot of docks are deploying on a rooftop, or if you're deploying this in a construction site, it's going to be in the fence perimeter, and your safe landing site is going to be inside that same perimeter. If you're doing it at a, utility solar field, like you're going to have that safe landing point in the same confines of likely the dock. And I know we moved it in order to give people a good visual as far as like when they were close to each other, they kind of overlapped, and so it was a little tougher to see, but. We'll go ahead, and at this point, we're going to launch this. You're going to see things will move rather quickly, so I'm going to talk through it as much as I can, and then Lamar will slow it down 10 speed for the video. But we have a start point and an end point. So the first thing is the dock is going to send the command to the drone to power on, and the drone right here, you can see the battery just blinked, and then this icon will go green. Drone is going to be turned on. You'll see a RTK signal satellite start to pop up. Also, here, the dock, you're going to see it's starting to open. So dock starting to open and drone camera is powering on. So we got nice, clear, imagery of from the drone and visual of the drone as it takes off. 22, 21 satellites. You'll see it just departed. The dock closes rather quickly. It does this because you can operate this in light rain and conditions where you don't want that dock to just sit open. You don't want moisture and things of that nature to just collect.
And this is going to 120 feet and then starting its mission, or is it at mission height of?
This is going
200?
Straight to that mission height of 300 feet, and then it's executing its mission. So you can see in this view, we have that live camera.
And I got to tell you, Paul, one of the interesting things is looking at the heights and seeing negative values.
It is interesting. What I'm pointing out as I zoom in is negative because it's below you, right? Negative being in reference to the drone. The dock is 300 feet below the drone. The drone is up here, and as that drone adjusts its altitude, it's a visual linear an instrumental way to display altitudes.
That helps with your situational awareness and safety.
And so those items we're used to seeing traditionally, as far as how high is our drone, what's our horizontal speed, what's our vertical speed, what's the distance from home, the same things we're seeing on our remote controller and this screen, and we're running all of this remotely through that software, that component that gives us all this data. As I move to the map, one thing that I think is neat, and the ability to move about this in real time on a computer versus a tablet in your hand, it's ease of operation. So here I have some great vertical. This is the same type of situational awareness you might see in a G1000, a glass cockpit of a flight deck of a modern citation jet, or a 172, a synthetic radar, right? So you can gain the sense of where am I in reference to the obstacles.
And I see that the height is changing so it is going from the ground up, the AGL. It's not from the dock station.
Correct. And so that ground below the drone is actually going down. And so we have to monitor as the drone, there's ways with newer software to import the ground elevation, whether that's through a GeoTIFF or an actual flight that you flew. And this way you can have the drone maintain 300 feet above ground level. This drone is currently maintaining an altitude of 300 feet.
From the docking station.
Correct. I don't know if there's any, just to see if there's any questions, Amy.
I don't see any questions yet.
Yeah, we can keep chugging along. Hopefully
there is one question, guys. I was on mute. I was trying to get to it. Ish is asking, is it using radar altimeter or GPS reference altitude?
It would be using GPS referenced altitude, and when it's giving it relative to AGL, there's some data that it's pulling from like the map data.
Hey, what's going on?
Cesium
I'm sorry, I was in
ion
the garage.
My name's Eli.
Hey, how you doing, Eli?
I'm
Okay.
doing
is
great. Sorry.
Cesium ion is like their map overlay, like a Google Earth or API, and so it's possible to pull some ground data, but no radar.
Well, I see we're getting to the end of this this flight pattern. And so is it going to stop or is it going to return to the base?
So at this point, it's automatically going to return to the base.
Okay. And you can adjust your camera view, correct? To go up and so you can see the horizon.
So in autonomous flight during the mapping mission, no.
Okay.
You're setting that angle. There is when you go into the manual flight mode, you have the ability to have full control. Just wanted to act like all funky. I don't know if you saw that.
I did see that. I was concerned for a second.
I'm curious, like why
Could it have been the camera being moved? Oh, and I see that your ground is now coming up pretty fast.
well, yeah, and what's interesting is we'll see if it kind of corrects itself. Leave it to like the live demo for this thing to land. Oh, you know what? It's the camera. It's because I double clicked the camera. See how the drone landed square?
Yep.
If anyone who watches the playback will find this interesting, the drone landed square. But if you looked at the angle of the camera, it was actually pointed because I double clicked the screen. You were asking, can I control it? And you can manipulate the angle and direction of the camera and the yaw of the drone in manual controls simply by clicking on a point on the screen. So what I most likely just did was created a bug by clicking on the screen in the middle of the drone entering a return to home state.
So now it is back in the box. And is it recharging?
It is recharging. And so you can see the charging state here.
And that 3.2, that minus 3.2, that is the altitude of the drone to the ground being in the charging station, correct?
In relation to the AGL to the ground, which is interesting because there's a slight, like the elevation of where the dock is in relation to the hill, like a 3 foot. So I think that's just as it's in the box, it's flat, but there's like a consistent,
3 foot.
yeah.
So we have a question from Jason. Are you ready for questions?
Yes.
Okay.
Yeah.
Can you go over geofencing? Is the question from Jason.
That's a great question. And Jason, you actually just set us up for for the next flight. So thank you so much. I feel like you knew what you read the script, the notes. So yeah, so go to location. So here we are, right? We just demonstrated and I promise this is answering your question, Jason. The mapping, right? We just demonstrated how we can plan a flight, 2D, 3D. We can plan these autonomous missions, but also what is remote, BVLOS pilot operations also being used for is for public safety, first responders, and you're deploying a drone to a known location on demand. It's like a Part 135 jet charter company. Hey, where do you want to go? Here. When? Now. Okay. Well, call comes in and some of these more advanced systems have automated it into the remote ops center. So if a call comes in, they can coordinate the call location, they can triangulate it using cellular. There's all kinds of ways to pick up GPS coordinates. Gunshots, you know, there's speakers that listen for gunshots, and they can triangulate that location. And there are drones in boxes that with the proper software will automatically fly there. Right here, what we're going to just demonstrate is manually commanding a drone to go to a known location. So instead of executing a mission, I can click go to location, GTL. Once I click GTL, I can click anywhere on this map. For instance, here, we want to go to this known location. Immediately, it gives us the GPS coordinates, and then it wants to know what safe altitude should we go to first. All right, go to 200 feet first. Climb to 200 feet out of the box, and then proceed to what altitude? Let's just say 300 feet. And so now you see, again, this elevation profile. We're going to take off, climb to 200 feet, and on the way to the location, we are going to climb to 300 feet. Great. We're clear of obstacles. However, if we look at the map, it's taking us right through a no-fly zone. All right, well, I don't want to have to map and pinpoint that out. So let's just, send it. So we're going to hit launch. Same checklist is going to come up. Do we have permissions? Is our latency good? GPS quality, RTK. Safe location is configured, yes, and status is healthy. Next. No rain, temperature is going down, and the wind is remaining calm. We're going to go ahead and launch.
When you launch that, when you said you had permission, you have permission to fly that no-fly zone? Is that what you're saying?
So the permissions would be more or less an ATC permission because this no-fly zone, it's automated. It's not asking you, it's not a permission to fly through a coded no-fly zone. That permission is you have permission, whether it's an ATC waiver, an authorization, you have the appropriate permissions to execute that flight.
Okay.
Yep.
So box opens up. Now that dotted line is not necessarily the line that did I bug out?
You bugged out for a minute, and Jason has a question about why does the number of satellites matter when the dot keeps track of them?
Yep. And so I did see I blipped out there because I actually saw the whole dock. So drone is taken off. We can see that here. And now it's going to fly. So the permissions section is ATC permissions, airspace authorizations, waivers. It's not about no-fly zones. Watch, you will see this drone is actually going to avoid that no-fly zone en route to its destination.
That's so cool.
And so when you're operating over a very large area, right, when you're operating over a town, couple square miles, you're going to have to map out high schools, because a lot of waivers and authorizations, they don't want you to fly over open air assemblies. What's an open air assembly? Well, a high school football game in Texas. If anyone's been to a high school football game in Texas, it's like a college football game in Connecticut. There's a lot of people there. And so you don't want to have drones flying directly over large groups of people, areas of security interest. There's a nuclear facility. Right here is a nuclear facility. You can kind of see it in the camera. We don't need to zoom in on it necessarily. But there's plenty of areas, police stations, prisons, schools, hospitals, heliports, airports, uncontrolled airports, airfields, just all those things. And so you can map those out one time as part of your initial safety and compliance requirement, right? Just to continue to say safety. You map it out once, you do an analysis, one time, and then you build that into your software and your system so that no matter what pilot comes through, no matter what day of the week it is, what time of day it is, how much experience the operator has, they're not going to have to memorize these these areas of higher risk. You can just say, this is an area of high risk and we don't want the vehicle to operate there. And so now those are your no-fly zones. That's an example of how this vehicle and this software has that real-time intelligence to navigate a no-fly zone, just like a pilot would when they're in an airplane flying and they have ForeFlight up and they're like, all right, that's a no-fly zone. This is an MOA. This is an alert area. I have to navigate this. Or you can have fancy GPS. So now what if I want to tell this drone to go cross this road, right? Go to this location. Stay at 300 feet, and I want you to go to this location, this GPS coordinate, this field. So I can hit launch. And now this drone is going to reach a geofence that it is not supposed to be right passing. So you heard that alert. You see the the pop-up wayline failed. It's telling you, no, right? You can't go here. You can't operate outside this prescribed, predefined area. I hope that was a visual long way of answering the question about the geofencing.
No, that's awesome. Now that geofence, that's what you put into the system, correct?
Yes, sir.
Okay.
So we have some questions in the chat, and actually what I'd love to do is Jason, Ish, and Chad, why don't you go ahead and take yourselves off mute and let's answer those questions.
Okay. So my second question was, why does the number of satellites matter when the dock keeps track of them?
Yep. So the number of satellites matters for the drone and the dock. So it's telling you how many drones your aircraft has, and I go back here. Currently, the drone can see 27 satellites. 21 of those are in the GPS system, and not all are RTK. So 27 of those in total are coming from other constellations. The dock also has a GNSS receiver built into it, a global navigation satellite system receiver. So dock has a GPS receiver and the drone has a GPS receiver. The dock knows its precise location. And so the satellites, and as this drone flies and moves, the dock is sending real-time corrections to the drone. So the actual precision of the GPS on the drone in real time is highly precise, down to centimeters versus your traditional 1 to 3 meters. So everyone always talks RTK antennas, and unless you actually have the corrections being sent to the drone in real time, it's just an attachment. And so that's what the dock has. The dock sees satellites and the drone sees satellites.
So you get an accurate representation of where you are so that you know exactly how high you are and the exact location of the drone, correct?
The point is for navigation. So when you want to mow your lawn with an automated lawnmower, that lawnmower can't see above the ground, right? That lawnmower, you don't want to put a camera or a LiDAR. So if you have super high accurate GPS, then you can do that with the real-time correction. So how you're actually navigating through space. The more accurate your coordinate is, the location, the more accurate your flight is. And then also it's important because when you're collecting data, you're geotagging pictures, you want the geo data on the pictures to be highly accurate as well.
Right.
So
Well,
Ish, did you get your question answered, or did you want to go ahead and pipe up on that one?
Well, the first question, Dr.
Yeah.
Google was able to answer it for me, but just so for everyone's clarity. So my question was, what altitudes do the geofencing go up to? And it's not relevant. So that the fence is a hard stop, period. But you can segment altitudes for that fence. So you can like basically cut off like an altitude block, and yeah, that was pretty neat. My other question is, Are you personally, with this drone in the box, are you experiencing any issues with the BVLOS landscape and the waiver approval as foreign drones get vilified?
No, I don't think the FAA doesn't look at it as far as where it comes from. It's just risk mitigation. It's severity and likelihood. And when they're looking at a waiver for any operation, it's separate from country of origin. It's safety. It's not security. I mean, security is important, but when you're talking about actually flying this vehicle, right, there are elements of C2 and command and control. But a lot of this comes down to how does that system function in normal flight, not being hacked, or overran or backdoored, because any system potentially has that architecture that is susceptible. So that's not what you're having to present, not right now. It's more or less, hey, this drone has these functions. I can hit this command at any time and get this drone to come back. I can go to safe altitude. I can install a parachute. And so this software and this architecture gives the operator the ability to mitigate risk in real time. Now, are there people at the FAA that want to, say, hey, what other way can we, slow things down? I mean, you could certainly create issues with waivers.
I just didn't know if NDAA compliance for like any kind of critical infrastructure is starting to be looked at the FAA level as far as these waiver approvals.
Well, you have to have two things, right? You have to have your authorization to operate beyond visual line of sight, but you also have to have your airspace. So if you're going to put these kinds of drones in, areas of military bases, anywhere of high critical security, there's probably traditionally already policies in like a nuclear facility, right? If the nuclear facility doesn't have some vetting system in place as far as what they're putting on those grounds, they might need a new director of that nuclear facility. I say that just I say that, yeah. And then the other thing is, what I would say, the other thing is, for some of these operators and manufacturers, it's like an example, DJI, they're doing a very good job at providing documentation to the consumer, because buying it is one thing, but then having everything written in Word to present to the FAA. Because I can make a drone in a box, but if I don't give good documentation to communicate to the operator how to operate it, you're never going to be able to communicate to the FAA how you mitigate risk. And so that's one thing that the all manufacturers of drones in a box, Skydio, Bring, Nightingale, right? There's a lot of companies that are all not just making the drones, but recognizing, hey, if I manufacture a plane, I have to make a operating handbook to go with it. I have to provide weight and balance data. And so we're past the point where you could kind of just, we're not past the point. If you're going to be doing these operations, you have to have the documentation to go with it. This is an RTK station that is sitting on top of the house here, that is used to calibrate the dock itself.
Because with this dock, you have to have a separate other antenna to get it to calibrate, correct? When you set it up, so you had to have this antenna.
You have to have, like I mentioned, when you put the dock down, and I'm gonna try to zoom down to the dock here. You have to tell the dock where the dock is. And once you tell the dock where it is, you leave it there, you don't move it. And that dock will use its precise location to feed back to the drone.
And I see at the top of the drone, you've got a wind gauge and a rain gauge. And is that your cameras in the wind gauge?
Yep, so great point out. That's your wind anemometer that's your rain gauge right there. It has heated, so when the temperatures get cold, it will heat that metal surface, so it won't melt snow or any kind of ice to it. Now, if you put it out in super cool conditions, it's not gonna, a foot of snow, a foot and a half of snow, it's probably gonna sit on there for a minute. And then that camera allows you to kind of monitor it, just like a Ring camera on, say, a house.
And how secure is that box?
You would bolt this down, so there's like 3 to 4 bolts that in each of the 4 legs here. So you would pour a concrete pad, and you would have, say it's a permanent structure or a long-term structure. You would pour a 4x4 or 6x6 concrete pad and have some eye bolts there that you could bolt it down, or you could bolt it to like a wood structure. We've seen construction sites where you can build up a platform, like a raised platform, so it's not sitting on the ground. And so if you just build like a small deck for the box, you can then just bolt the dock directly to a wood structure.
Well, I tell you what, we're at the last 8 minutes. Why don't you show some of the features of the camera? The wide, the zoom, the thermal, the multiple imaging.
And
Yeah,
Chad,
we'll go.
hold on just a second. Chad, did you get your question answered?
I did not. Just really
I'm
quick
sorry.
though. Should be quick.
Yeah.
It's just an overall question of like FAA and beyond line of sight. To your knowledge, is the FAA or other organizations taking steps to improve real-time visibility of beyond visual line of sight? And are there efforts underway to use current sense and avoid technology and network connections to create a safer national airspace for manned and unmanned air operations?
Yeah, that's a really good. That's like a Lamar question right there.
Yeah, they're working on it. They have to, because the only way that you're going to have aerial taxis and delivery service up there is to have a system that can communicate with each other. So right now you've got a lot of these independent systems that are proving their worth for doing moderate deliveries and operations such as that. But it is definitely one of those items that is being worked on. And the only way for this to successfully go to the future is if these systems can communicate with each other. So we can keep the airspace safe. As far as progress, I don't know where we are on that, but we did have some news today, didn't we, Paul, about DFR?
Well, I think network-based
Yeah.
remote ID on the commercial side. I think DFR side, we've saw at the end of last month and this month, at or below 200 feet, the FAA is kind of saying, hey, if you're below 200 feet, like right now, we're at 138 feet, 140 feet, and so we're kind of at the height of the trees, and this is shielded. This is starting to become less risk, not so much to the people on the ground, but to the aircraft in the national airspace system. So from a public safety side, they're saying, hey, to save someone's life, it's looking like, putting in the waivers, but being able to fly a drone 150 feet off the ground in close proximity to structures, buildings, towers where airplanes don't fly, that's happening. And that I would say that has to happen so that these companies can, we want American technology and manufacturing to grow. And this is a huge opportunity for what we're better at to do, because it's not about bulk and volume and scale. It's about doing something well and safe and secure. And that's what we do, right? We don't just do a lot. We do a lot here, but we do a lot well. And on the commercial side, it's network-based remote ID and UTM. So network-based remote ID is saying right now I'm maintaining visual line of sight. I have a waiver, right? We've worked with agencies and organizations to do limited shielded BVLOS and EVLOS, which is like extended visual line of sight, a VO. But we don't have network remote ID yet. We have remote ID, right? Right now, this drone that's flying, it's broadcasting, but it's only going so far, right? It's just a Wi-Fi broadcast. No one that's outside visual line of sight of this drone is going to be able to see me on a map. But I'm connected to the internet right now, right? I'm flying this drone on the internet. The only way for me to fly this drone remotely is connected to the internet. So how easy would it be right now for this drone to push its location to the cloud? But whose cloud? What cloud? Where's the cloud? Who's running and managing the cloud? That cloud for airspace, that to me is UTM, unmanned traffic management. And so once I have the data and I'm plugged in and connected to the cloud, how does everybody else get plugged into the cloud? And so the drone is now going into the return to docking station. Hopefully I'm sure I can't answer your question, but
No, you answered it the best you could. So that was helpful. Thank you.
and so
It is.
yeah,
I
and
was-
so I was going to say, just like up here, time remaining, it tells you, just like on a remote controller, you have green, yellow, red, and it's telling you what, how much battery life you have, what's your fuel remaining. And when it gets down to a certain percentage, the drone is going to say, hey, let's go home, let's go home. And you can see these numbers. As the drone gets closer to the ground, it will turn red, right? Hey, you're near the ground. You're near the ground. Warning, warning.
I got to tell you, Paul, the thing I found so remarkable about this presentation is the fact that you and I are in different cities, and I am watching a live feed of something that you are filming in your backyard. It's, to me, it's
and,
amazing.
And that's going to go way, and it is amazing. But just to point out, network frequency and stats, the safety side, monitoring in real time, right? The network quality, the latency, the streaming, right? That's super, super important. And that is how we're doing this, right? You're here, I'm here, Amy's
Amy.
there, everybody, and then everyone else is where they are. And we're bringing this all together through a cloud, through that online connectivity service. And so hopefully, not only was this a little bit interesting and not the normal slides and stuff, but it was somewhat informative in regards to the state. Like people scratch their heads. So I know what a drone is. I get this aspect, but how does the operator, how does this all tie itself together? And we're just scratching the surface.
It is. Go ahead.
What was the acronym called earlier when latency was mentioned for the dock?
The acronym.
I
Return to
remember it was
docking
like
station.
CT, I think it was.
Oh, RTDS, return to docking station. Is that the one?
Okay, I think it is the one because I remember a T in it.
Yep,
Okay.
RTDS is return to docking station. So instead of return to home, it would be it's return to docking station.
And you can see that, this is a amazing system for those dull, dangerous, and repetitive missions that human error can creep in just because you're doing it so often. So this is essentially a great drone for like fire and rescue, or for a construction site monitoring, mine excavating. There's a number of different types of industries that can take advantage of utilizing something that they have to have the drone go up on repetitive missions.
Yeah, we didn't have any airplanes fly by or fly over. We would have captured that with the ADS-B, the onboard ADS-B in, and like you said, monitoring crowds, stadiums, schools, anywhere, lakes. I just think I always go back to public safety because I don't know what the heck's going on here. I'll go back to the slideshow now, and is I just think public safety, because you put these things in areas where like you don't have like high call volumes, you don't have to keep, the doc isn't going to complain traditionally. I've had, right, you mentioned it, they're about a year old now, and You know, there's no complaints about I'm hot out here, it's too cold, it's windy. There, it's just ready to go, ready to deploy. And so whether that's a lake, a river, you know, these calls come in, and then organizations, construction, utilities, solar energy. How much time does it take somebody to physically go to a location, get there, take the drone out, set it up? Did you forget something? Do you have the right thing? Do you, you know, yeah, the all the extra items and checks and things that you go through versus being able to kind of focus in. It's
Yeah.
I got one
I
more question, Paul.
Yep, go ahead. I think probably got time
Um,
for one more.
So why were there different acronyms for for monitoring purposes? I understand you went over RTDS, but there was another acronym I saw.
Yeah, the other acronym was uh, safe go to safe altitude, GTSA. The one other altitude that's important when you're flying is GTSA. So GTSA is go to safe altitude. Think about during this flight, if an airplane flew by at 600 feet, right? If we're at 300 feet and a plane is at 600 feet, we could hit GTSA, go to safe altitude, confirm that command, and the drone would immediately descend down to 120 feet. And so your GTSA, your go to safe altitude, is a pre-programmed altitude that you can immediately command the drone to go to in the event of an emergency.
Good. Good. And I noticed we forgot to add Lamar's website to this page. I put the links to both Paul and Lamar's website in the chat if you want to grab those before we log off here.
Yeah.